so that should have been enough time to do those 3 warm-up problems. Okay, what is the domain of the first one? Except x can't be 0. Yeah, you needed the x part in the first thing that you said. Okay, so here it's all real numbers with the exception of x cannot equal 0. And how did you come up with that, Claire?
That's what makes the denominator 0.
We don't want the denominator to be 0, so we're only looking at the denominator in terms of the domain. Yes? Okay? All right? Second one, what did we come up with? I know half of you didn't do it, but you should be able to do it in the 5 seconds that it takes me to finish this sentence. Luke, what you got? No. I want the domain. You gave me the vertical asymptote. Right?
All real numbers except x cannot equal -5.
Bingo. All real numbers except x cannot equal -5. Oops. I'm going to move that now. Hi, caramba. Things are going haywire. Up in here. Up in here. Okay. All right. Third one. What do we got for the third one?
All real numbers except x cannot equal 5.
Except x cannot equal +5?
Yeah.
Okay. I think there's 2 of them up there for you, Brad. Okay? With me? Okay. Again, domain is different than vertical asymptotes. Okay? Okay? It matters how we're saying things. Okay? I don't go into a French class and start speaking Cantonese. Okay? Probably not going to do very well in that class. Okay? When you come into math class, you got to speak math. Okay? Just something you got to do. And there's different ways of saying things. Okay? All right? And we're going to explore that now on this next page where for you and a shoulder partner, I'm going to give you, 10, 15 minutes or so to struggle yourselves through this chart. Okay? All right? Have at it. So, in the whole grand scheme of things, what is the first thing that you should find of those 4 things that I'm asking you to find? I'd find the domain first. Okay? That's what I would find first. Okay? Because does it take any graphing, picture, anything like that to find the domain? No. What's the only thing that it takes or that it requires to find the domain?
The vertical asymptote.
No. What am I looking for in the domain? The value of x that makes my equation undefined. So what am I looking at in my rational function? We just did 3 of them. What about the denominator?
What number makes it equal to 0?
What makes the denominator equal to 0? Okay? So it's what makes the denominator equal to 0. So in this first one, what makes the denominator equal to 0? 1. So this is all real numbers with the exception x cannot equal +1. In the second one, all real numbers except X cannot equal negative 2. Oops, that's a bad double R. Third one, all real numbers, but X cannot equal 5. Last one, all real numbers, but X cannot equal negative 4. Now, did you notice anything?
They're the same as the vertical asymptote.
No, they're not.
Well, the last number.
They're what, Jacob? Same as the C value. So the restrictions oops, that's like an 8. So the restrictions there are the C values there. Right? Okay. What would the next thing that you find be? Vertical asymptotes. Where do the vertical asymptotes come from?
Domain.
They come from the restrictions of your domain, right? So, what is the first vertical asymptote? X equals 1. Second one, X equals negative 2. Third one,
X equals 5.
X equals 5. Last one,
X equals
X equals
negative 4.
negative 4. Notice anything else about that? They're the same as the C value, right? Okay. So these are just X equals C are my vertical asymptotes. Right? Okay. Or you take off the not equal to part, and then there are the restrictions, right? Okay. See that pattern? That pattern will always be there. That's why the very first thing that we told you last week Friday was find the domain. Okay. Last week Friday, the first thing we started you with was what makes these functions undefined? The domain. Find the domain of these functions. Okay? You're going to do that every single time. Find the domain. Okay? Then, after that, now what do we have to do?
Gotta graph it.
Now we're going to have to graph it because the horizontal asymptote and the range all come from the graph. So step number 3, oops, wrong color. Step number 3 is we need to graph it. Okay? So, the first function I graphed was the first one. Actually, we can go like this. No one can see it still. There we go. Okay? So there's the first function that I graphed. Okay? So, 2 things that I need to look off of here. First off, I know that this one has a vertical asymptote at x equals 1. I know that, right? So my function can't cross over that vertical asymptote. Okay? Now, I have to look at where my graph is going. So in this case, my graph is blue. Is my graph going everywhere above the x-axis? Is it curving up somewhere? Yeah, it's curving up right in here. It's going up, right? Okay, so that means I go from positive infinity all the way down, 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 down. Okay, then I get down here to this 0 part. Does this part over here, way over there, does that part ever touch 0? Okay, all right, so we're not touching 0 there. Then we pick up at 0 way over here. Is that part on the left side ever equal to 0? How do we know mathematically, how do we know that that function 1 over x minus 1 will never be 0? Nope. Without even looking at the graph, I know that this function will never be 0. We talked about it the last 2 class periods. How do I know that that fraction will never, ever be 0? Talk to me, Haley. Because the numerator isn't 0. In a fraction, the only way a fraction can be 0 is if the numerator is 0. Okay? This numerator is 1. Is there any chance that 1 will be 0? None. So I know for a fact that I don't go to 0. So that's got to be a restriction in my range. Because my function never has a value of 0. But then it continues on and it goes down, right? Will it go down forever and ever and ever? So we'll go all the way to negative infinity, right? Okay, so let's put that into play. So the range then is going to be all real numbers with the exception of y cannot be 0. Because I hit every other y value except 0. And I know that because fraction logic tells me that that fraction will never be 0. Okay? So the fourth thing that we could find then would be the range. And then last we would find the horizontal asymptote. Now, if you want to flip-flop those around, you can flip-flop those around. Okay? So, how do I find my horizontal asymptotes? Talked about this the last 2 days also. How do we find our horizontal asymptotes? It's the end behavior. Okay? So I'm looking at the extremes. Well, way over here on the left side, what's my function doing? Way over there, where's my function? Approaching. Way over here on the left? It's no. What's my function doing? Function is blue. It's approaching what? From below. Okay? Way over here, what's my function doing? Approaching 0 from above. So at both ends, it's approaching 0, right? So what's my horizontal asymptote? No, that's a number. Say it louder. Y equals 0 is my horizontal asymptote. in number 2, or in the second one, I should say, there's my graph. I know that I have a vertical asymptote at -2. What's my range? What do you got is? What's the range of the red function now? No, y can be -2. It's right here. Right there, my function's -2. What's the only value my function can't be? 0. So how do I say that for terms of a range? All real numbers, y cannot equal 0. Okay? At the ends, what's my function doing? At the ends, what's my function approaching? So on the right side, it's approaching 0 from above. Left side, 0 from below. Right? So what's my horizontal asymptote? Y equals 0. Okay. Next one, without even looking at it. Horizontal asymptote or range? Give me one of them. What's that one? Horizontal asymptote would be y equals 0. I would agree. The one here in black. Okay. Range. Range of that one. See the pattern yet? For all of those, the range is just all real numbers but can't be 0. Okay? Later on this week, we'll adjust that so that your horizontal asymptote isn't always y equals 0. Okay? But the default horizontal asymptote is y equals 0. Okay? Just like the default, if it was just 1 over x, then x equals 0 would be our vertical asymptote. Today and tomorrow, we're moving around that that vertical asymptote. Okay? So, now, without a calculator, okay, on this one, what's the domain? Without a calculator, what's the domain?
All real numbers.
All real numbers. That's how domains and ranges start.
0. I forgot to say it, but I know it is.
X cannot equal 6. Okay? So if that is our domain, then what is the vertical asymptote? X equals 6, then, is the vertical asymptote. Okay? Based off of the last 4 examples, what is the horizontal asymptote?
0.
0 is a number.
Y equals 0.
Y equals 0 is a horizontal asymptote. Can this function ever be 0? Nope, because the numerator can't be 0. Okay? Vertical let's start with the domain first over here. Domain.
All real numbers. X is not equal to
X cannot be -3. So that means my vertical asymptote is,
-3.
that's a number.
X equals negative.
X equals -3. Horizontal asymptote.
Y equals 0.
Domain over here.
Are real numbers, x cannot equal 2.
So that means my vertical asymptote is,
X equals 2.
and my horizontal asymptote would be, there they are verified. Okay? X equals 6 in the first one with the vertical asymptote, y equals 0 with the horizontal. Tough to see it in this middle one here, but it is y equals 0 still. Still has a vertical asymptote at x equals 3. Same over there. Okay? Determine the general formula to identify the vertical asymptote of a rational function of the form g of x equals that. What's the vertical asymptote in that general function? C is a letter. X equals C. You gotta say it right. Okay? You gotta say it right. Because if you just wrote 6 on a test, it would be marked wrong. Okay? So this one here is X equals C, is my vertical asymptote. Okay. VA stands for vertical asymptote. What generalizations can you make about the C value and the domain? Well, we've already talked about that too, that the restrictions are X cannot equal C. Okay? So the restrictions of the domain then are X cannot equal C. Okay? Without a graphing calculator, determine the domain, the range, the vertical, and the horizontal asymptotes for each function. All right? That should take you about 3 minutes. Give you 1 minute per problem. Go. We'll talk g of x first. Domain of g of x. All real numbers. X cannot equal 0. Okay? Marley, what's the vertical asymptote then? X equals 0. Daniel, what's the horizontal asymptote? Y equals 0. Do we not do range? Never put a spot on there for range, did I? Yeah, but it wasn't in the directions to do it in the last one. Is there a spot on yours for range? Oh, well. Range. What's the range here then? Y cannot equal 0. Yep, so this is all real numbers, but then y cannot equal 0. Okay? Jacob, domain of the next one.
All real numbers. X can't equal -10.
Okay? Luke, range.
All real numbers except y can't equal 0.
Okay? Vertical asymptote, David.
X equals -10.
Erica, horizontal asymptote. Y equals 0. Is domain over here. Haley, range. Destiny, vertical asymptote. X equals 7. Brad, horizontal asymptote. Y equals 0. Good job, everybody. Okay. Okay. What? Now it's going to get super hard? No. Because everything builds off of this. If you start every single problem, don't get me wrong, the problems are going to get more complicated. But if you start with, you first find the domain, then you find your vertical asymptotes, then we're going to teach you a shortcut eventually about how to find the horizontal asymptotes, and then go on from there. There's a 7-step process to solving these, or to graphing these. That's eventually what we're going to do. We're going to graph these without the graphing calculator. And it's a 7-step process. And if you follow those 7 steps every single time, you're golden. Okay? All right, so now, number 3 here says, write a rational function from the graph, table, or description provided. Okay? So, part A says it has a vertical asymptote at x equals 3, and it has a horizontal asymptote at y equals 0. Okay? Well, we've just done 7 or 8 different ones that had horizontal asymptotes at y equals 0, right? Okay? But so how, if x equals 3, then that means that my denominator is going to have something in it. And what's that denominator going to have in it? Just -3? X minus 3. Because then this is saying that x minus 3 would equal 0, right? Which is saying then that my function, my rational function, would have some value of x minus 3 down there. Now, if I wanted to square it, or if I wanted to cube it, or whatever, I would just, but it's got some value of x minus 3. Okay? Then, what can I put up on top? 1? Does it have to be 1? What?
Is there any number that's not 0?
Any number that's not 0 and doesn't have a variable on it, right? Okay, so if you wanted to pick your favorite number, you could put your favorite number up there, as long as it's not 0 and there's no variable up there. Okay, so I'm going to go with the first number that I hear. I heard 12 first. Okay. All right. Do part B. So the question was, you can put the same number up there every time if you want. And the answer is yes, provided that your horizontal asymptote is y equals 0. Okay? If your horizontal asymptote changes, then the numerator is going to have to change to go along with it. Okay? So, what do we got up here? We've got x equals -2. So that means that x plus 2 equals 0. So my function is going to have something over x plus 2. Don't know why I put that in parentheses. Oops, now I erased my 2. So now I'm just going to restart right over. And what needs to go on top? 3? As long as it's not 0 and it doesn't have a variable attached to it. Okay? So now off of a table, here's my undefined, which means then that x equals 2 is my vertical asymptote. Correct? Which means then that x minus 2 is going to have to equal 0. So that means that my denominator, Destiny, I know, but put the phone away. That means that my denominator is x minus 2, What do we want my numerator to be? Anything. What do we want it? 1. Boring. Okay. Now, actually, I lied. In this one, if we put 3 in there, no, our denominator can't be 1 in this one. Our numerator can't be 1 in this one. No. It's gotta be 2. Why does it have to be 2? Because we have points that work out, right? So if we plug 3 into my function, okay, so if I find h of 3, I don't know why this arrow is coming along with me for the ride. If we have h of 3, then that's going to be 3 minus 2 down there, right? We'll call this x. Well, the value here then is 2 equals x over 1. So h of x there has to be 2. Okay? It's locked in because we actually have points. If back up here, we didn't. We just had the asymptote, so we could have any number there we wanted. But down here, we actually have points. So over here, it appears that we have a vertical asymptote right there at x equals -3. Agree? So that means that my function is going to be over x plus 3, correct? What's going to be on top? Well, let's use this point right here. So then k of x is 1. I don't know, actually I shouldn't use x. Let's use question mark. Question mark is over x plus 3. Okay? So, oops, not over x plus 3, over -2 plus 3. What's -2 plus 3? 1. So this is 1 equals question mark over 1. What's my question mark got to be? It's got to be what? 1. Okay. With me? We'll finish up this packet tomorrow.